Your left hand and your right hand are perfect mirror images of each other. You can place one on top of the other, but they will never perfectly align. No matter how you twist or turn them, your thumbs will always point in opposite directions. This simple property known as chirality is more than just a biological curiosity. It's a fundamental feature of our universe. The molecules of life, the amino acids and sugars that build our bodies, almost exclusively exist in a left-handed or right-handed form. This isn't a random choice, it's a deep, cosmic preference that scientists are still struggling to explain. What if our universe itself has a preferred handedness? Imagine our cosmos as a single massive entity with its own set of rules and properties. The weak nuclear force behaves differently depending on the spin of a particle, violating parity conservation. It's as if the universe has a secret handshake. Imagine you are standing in front of a perfectly still lake. Your reflection gazes back at you, identical in every detail, yet fundamentally reversed. This is the core concept of the mirror universe applied to the entire cosmos. It's a parallel reality that is a perfect spatial reflection of our own. Particles have a property called spin, like a tiny spinning top that can be either left-handed or right-handed. In our universe, the weak nuclear force overwhelmingly involves left-handed particles. Think of a screw. A standard screw tightens clockwise with a right-handed thread. You could design one with a left-handed thread that tightens counterclockwise. Our universe is like a cosmos built with right-handed screws. What if you not only reflect the universe in a mirror, but also swap all particles with their antimatter counterparts? This combined operation is called CP symmetry. Our universe's imperfections might be perfectly cancelled out by its cosmic twin. At the very beginning of time, just moments after the Big Bang, the universe was a searingly hot soup of energy. This energy should have produced matter and its strange counterpart, antimatter, in exactly equal amounts. For every electron, there should have been a positron. When a particle of matter meets its antimatter twin, they annihilate each other in a brilliant flash of energy, converting their mass back into pure light. If matter and antimatter were created in equal measure, they should have annihilated each other completely, leaving behind a universe filled with nothing but light. Yet, here we are. The planets, the stars, the galaxies, and you. All of this is made of matter. For roughly every billion pairs of matter and antimatter particles that destroyed each other, just one single matter particle survived. This tiny remnant is what formed everything we see today. What if the matter and antimatter were somehow separated? Some theories propose that our universe ended up with all the matter, while its mirror twin became the repository for all the antimatter. Our universe's apparent surplus of matter isn't a surplus at all. It's just one side of a cosmic coin. At the smallest, most fundamental scales of reality, space and time are not smooth and continuous. They dissolve into a chaotic, bubbling sea of possibility known as the quantum foam. Tiny fluctuations in energy can spontaneously create pairs of virtual particles that pop in and out of existence in fractions of a second. The many worlds interpretation suggests that every time a quantum measurement is made, the universe splits. Every possible outcome becomes a reality in its own separate, parallel universe. Imagine you're at a crossroads and can turn either left or right. According to many worlds, the moment you make a choice, the universe splits. In one universe, you turn left. In another, a copy of you turns right. Perhaps the Big Bang itself was a singular, massive quantum event that created not just one universe, but two, locked in a symmetrical embrace. They would exist on different branes of reality, separated by a dimension we cannot perceive, yet potentially able to influence each other through gravity or exotic forces. The amino acids that make up all proteins in life on Earth are, with very rare exceptions, left-handed. The sugars, like the ribose in our DNA, are almost exclusively right-handed. This universal preference is known as homochirality, and it's a complete mystery. Why should life choose one hand over the other? In 1997, scientists analyzing the Murchison meteorite found an excess of certain left-handed amino acids. This suggested that the bias for left-handed building blocks of life might be cosmic in origin. Perhaps circularly polarized light from neutron stars or supernovae preferentially destroyed right-handed molecules in the interstellar dust clouds where our solar system formed. In a mirror universe, life would be constructed from right-handed amino acids and left-handed sugars. Such life forms would be visually identical to us, but their biochemistry would be our mirror image. If you were to meet your mirror twin, you could not share a meal. The food from their universe would be indigestible or even toxic to you. If a mirror universe does exist, how could we possibly detect it? This other universe isn't just on the other side of the galaxy, it's in another dimension entirely. Unlike other fundamental forces, gravity is incredibly weak and might be able to leak between dimensions or branes. Physicists at Oak Ridge National Laboratory fire a beam of slow-moving neutrons at an impenetrable wall, looking for a bizarre outcome. A neutron that vanishes from our universe, passes through the wall by crossing into the mirror universe, and reappears on the other side. This theory suggests that particles might oscillate between our world and the mirror world under the right conditions, particularly in the presence of strong magnetic fields. Perhaps the most direct evidence could come from the Large Hadron Collider. Physicists smash protons together at nearly the speed of light to see what exotic particles emerge from the wreckage. If mirror particles were created in a collision, they would escape unseen, but they would carry away energy and momentum, providing a tantalizing whisper from the other side. In the desolate, frozen landscape of Antarctica, a NASA-sponsored experiment called ANITA has been scanning the heavens for ultra-high-energy cosmic neutrinos. It consists of a massive balloon carrying radio antennas high into the stratosphere, detecting faint radio pulses when neutrinos from deep space smash into atoms in the Antarctic ice. ANITA has detected something utterly baffling. Radio signals that don't seem to be coming from space above but rather bursting up out of the ice from below. High-energy neutrinos should be absorbed by the Earth. They shouldn't be able to pass through thousands of kilometers of rock and ice to emerge from the other side. A group of physicists proposed that these anomalous events could be evidence of a CPT symmetric universe where not only are charge and parity flipped, but the arrow of time itself runs backward. A particle from this time-reversed universe would appear to us as traveling backward in our time, precisely what ANITA observed. It's incredibly speculative, but it remains a genuine, unexplained observation. The idea of parallel universes was built upon the shoulders of giants. Andrei Sakharov was one of the first to propose that matter-antimatter asymmetry could be explained by processes that violated CP symmetry. Hugh Everett III's many worlds interpretation was initially dismissed but later championed by physicists like Bryce DeWitt, fundamentally changing the conversation about parallel realities. Chien-Shiung Wu conducted the famous Wu experiment in 1956, proving that the universe can tell the difference between left and right. This discovery was the first empirical crack in the mirror of cosmic symmetry. Modern physicists like Leah Broussard are pushing these ideas from theory into testable experiments, representing the frontier of physics exploration. The journey to understand the possibility of a mirror universe takes us to the absolute limits of human knowledge, forcing us to confront the deepest mysteries of our existence. The mirror universe offers a solution that is as elegant as it is profound. Perhaps our universe is not the whole picture, but one half of a perfectly balanced whole. This transformation would be as significant as Copernicus realizing Earth wasn't the center of the universe, or Hubble discovering our galaxy is just one of billions. Of course, we must remain grounded. The mirror universe is still highly speculative, and science progresses through rigorous testing and falsifying hypotheses. Yet its power lies not just in potential truth, but in the questions it forces us to ask, and the creative experiments it inspires, pushing the boundaries of technology and theory. As we peer into the cosmic looking glass, we may only see our own reflection for now, but the possibility that the universe has a hidden twin makes the quest for knowledge the greatest adventure of all.